Welcome to the third update video on my project building a mixed reality drone racing game. I've been working on this project for a few months and I'm really excited to finally share this update because this is the first complete proof of concept that shows all the core pieces working together. It's the first time I can tangibly point at something and say, this is what I'm working on. In this video, you'll see a clear example of how this game works and get a preview of the updates I'm planning next. So without further ado, let's get into it. In the last video, you saw me add in a basic camera feed and gamepad input, which is the first time the game was actually playable. With my previous updates, I could fly the drone using a gamepad through Unity, and I could see its position in a virtual room alongside the FPV live stream. The big challenge from last time, though, was not being able to focus on the two separate video feeds. It just wasn't practical to watch one feed to see where the gates were, and another feed to make sure I didn't crash into anything. This was actually pretty challenging and made the game pretty frustrating to play. So for this update, my big focus was on getting these two video streams unified into a single mixed reality view where you could see the virtual objects like racing gates directly overlaid onto the FPV live stream. I'm happy to say that I got there, so let's see what that looks like. The first thing you'll notice is that the game view is now just the FPV feed without the 3D modeled room that used to be there. Additionally, you'll also see a few new displays which just show some relevant information like battery charge and remaining runtime. For this recording, I also edited in an overlay showing the gamepad inputs just so you can see what I'm doing, but that isn't part of the game just yet. Just like last time, I'm using the gamepad controller to fly the drone through Unity. And as I'm flying around, you'll see some virtual gates overlaid in the view, which are located at fixed 3D positions in the room, or at least they're supposed to be. And of course, just like last time, I can interact with these gates, so for example, as I fly through them, they change colors. Now, pressing the start button lets me begin a time trial to see how fast I can complete a race. After I finish the race, we can see some quick stats show up too. Since the drone's entire trajectory is being tracked during the race, we can compute some interesting stats here. I'm planning to add more in the future, so for now this is just the basics and some placeholders. So obviously this is a very simple racetrack with just a single lap through one gate. But we can use the game's new track builder tool to make more complex tracks as well. And that's what I want to show you next. So as the name implies, the track builder helps you build your own custom tracks. The main idea is that you basically use the drone's position estimator to place virtual markers in your physical 3D space. Then you can use these markers as reference to place your gates and other virtual objects afterwards. The actual workflow is still a little rough and requires working in Unity's edit mode for now, but the concept and the approach should still be pretty clear. First, from edit mode, we enable the track builder object in the scene hierarchy, then enter play mode. Next, we take the drone and the game controller and walk around to different locations in the room that we want to place markers at. When you press the triangle button, the track builder will save a measurement of the drone's current position, along with a snapshot from the camera feed. You can also delete these markers by pressing the square button as well. So basically, you do this process of walking around the room with the drone and leaving markers until you're satisfied. I generally leave markers where I want the gates to be, but you can also use them to label other important locations, such as obstacles you want to avoid or specific spots in the room. Basically, these markers will serve as reference points for the next step, which is where we build out the actual track. Once we're happy with the markers we've placed, we come back to Unity and click the Save Track checkbox. This will just save a JSON file with the marker positions as well as JPEGs of the camera snapshot from each marker. Then after that, we can exit play mode and switch back to edit mode. Next, we can click the Load Gates checkbox to automatically load the markers we saved, as well as place an oriented gate at each marker. Now from here, we can add or delete any gates we want and place other virtual objects in the space using the markers as reference. Here, I'm just using one of the gate markers to place a landing pad in the scene, along with a little slime character that follows you around with its gaze as you're flying. So basically, I'm just copying that gate's position over to the landing pad and getting rid of the gate since it was just a reference for me. Once we're happy with our track, we just disable the track builder object, enter play mode, and we can start racing our new cars. So like I said, I've been super excited to get this video out because it finally shows a clear depiction of the gameplay concept for a mixed reality drone racing game. This is still just the beginning, but hopefully it's a little easier now to understand how it might work. In terms of what comes next, I generally want to focus on developing the gameplay experience, but there are a few specific improvements I'm looking to make as well. The first of these is improving the drone's position tracking. As I'm sure you noticed, the gates don't appear totally stable and slide around sometimes pretty dramatically. Right now, the position is still just being computed by the onboard state estimator with the internal IMU and a single lighthouse base station. This seems to work pretty well around like 80% of the time, but needs a direct line of sight between the drone and the base station, and the positioning degrades pretty quickly without it. Another key improvement I'd like to make is to the flight modes. Right now the drone only works in position hold mode, which is pretty conservative. This is mostly so I don't crash, but it's also pretty limiting when you're trying to do any real flying. And a related improvement is to design and 3D print a camera mount and some safety guards for the drone so that things are less exposed during crashes, which has already happened a bunch and is definitely going to keep happening as I start playing around with the flight modes. So those are the next big updates I have in mind, but I'm always open to other suggestions as well. If any of this work sounds interesting to you, please check out my Hackaday project page, which is linked in the description. That's where I post more detailed project logs and where you can also message me. So thanks for watching this whole video, and I hope you tune in again for my next update. See you again soon.